Testing. 1, 2, 3. 1, 2, 3. What? Jaké services? Budou tam. Všechno tam bude. Everything will be needed. Microservices, containers, everything. Yeah. No.
So hello, welcomers. We'll start with the next presentation. It's a pleasure to introduce you Marek Schmidt, who is a senior quality engineer in Red Hat JBoss. Is it JBoss? Yeah.
Hello. Thanks. So hi, I'm Marek Schmidt. This presentation is integrating middleware in the cloud. It's really about Fabric8. Now Fabric8 has already been mentioned several times already today, this year. So I guess you're all eager to know what it really is. And I managed this presentation to be kind of introduction of the concept of containers and Kubernetes, Docker and stuff to the middleware crowd. So I guess I can ask a question. So who here doesn't know about Docker yet? Everybody knows about it. Is there anybody who have never run Docker run? Okay. And what about Kubernetes? Is there anybody who doesn't know anything about Kubernetes? Okay, sometimes. Perfect, fine. So, cloud. So what makes cloud special that we need to have any project that's specific to clouds and stuff like that? Surely we can just rent some instance on Amazon and deploy a Java EE server to it and some applications to it. And you could be said you're running in the cloud, but that you're not really using the cloud to its full potential. So there are some concepts that I think are important to understand what Fabric8 is about. And these concepts are containers, immutable infrastructure, and microservices. So first, containers. So why do we want to run on clouds in the first place? So as with anything, the answer to that is because we want to save time and money. So time. If you want to provision some service, if you don't have clouds, you need to order for some physical machine, and it takes 2 weeks to get to. This chair is really annoying. So why in the clouds you can just click some button and provide your credit card details, and you have some infrastructure. And money, that means you want it to be cheap, as cheap as possible. And that means you probably don't want to rent the whole server. You may be comfortable if you're just using parts of it. I mean, you share the server with someone else. And the cloud providers will, of course, if they need their price to go to the bottom, they need to pack as many applications as possible. So what they really need to do, some kind of virtualization that is as much efficient as possible, is as little overhead as possible. And that's what containers are mostly about. If you never heard about containers, you probably have anyway, so we've probably seen some picture like that, comparing virtual machines to containers. On the left side, we have the virtual machines. So suppose you have some application A and derived A, even if they use the same binaries and libraries, then there needs to be copies of those, including the whole guest operating system running. Whereas with containers, they can potentially share the binaries and libraries, and since they also share the CPU of the server, and there's only one scheduler of the host operating system, and they use the whole memory pool of the server. that means it's much more efficient. So you can pack more applications into the server. That's great. Immutable infrastructure. So one other thing you want to do with clouds is that you may want to, like, on-demand spin up several tens, let's say, instances of your service somewhere. Or you may want to move your application from in between nodes and stuff like that. And the only reasonable way how you can achieve that is if you 100% automate the provisioning of your application. And if that means you either have some kind of golden image that gets copied somewhere and then just executed on the infrastructure that gets created for those, or you have some script that is executed when you say you want to run it here. It doesn't really matter. But the point is it's 100% automated. And if you have those creation in some kind of image or script, that means it doesn't really make sense to modify the running application, like trying to fix things by updating it at runtime or just managing it. It just doesn't make sense because you have to, if you want to fix anything, you have to fix the image anyway. So then it's just cheaper to just kill the old broken image and start a new image from the new application from the new image. Okay, so that's the concept of immutable infrastructure. I guess I've already said that. Yeah. So in case of failure, you throw the container away and spin up another one. And if you want some kind of script or image, the point is, of course, that this script has to be completely portable in between environments, and that allows you to rapidly scale up and whatever. Microservices is the third of the concepts. Already mentioned it, probably heard the keynote. So what I want to say, so another thing you want to do with clouds is, usually you want your applications to be scalable, and that means running multiple instances of those, and any complex application probably has more scalability domains, so we have, like, say, front end and back end, and the front end probably scales based on how many users just access the web page, but some business logic behind that is maybe just is not dependent on that. You also want to be the whole thing want to be fault tolerant, so if the infrastructure in some nodes crashes, you want the whole system to work. So you can't just have everything running in one of the containers. You have to run on many containers, somehow connected. And that basically means you have to use the microservice architecture anyway. So what it is just an architecture design pattern. That means you have independent services that are loosely coupled. The independent means they're run on their own somehow, and they're loosely coupled. It means that you want the communication protocol between these services is based on some standards usually. So we probably want to use some web services, or maybe messaging, some in the form of queue topics and stuff like that. There's another aspect which I'm not mentioning here. In Java world, the term microservices usually means running your application without the application server. As for stuff like containers on running the thing on Docker and for Fabric8, it doesn't really matter that much because in some level you anyway have some process that just exposes some port. I mean, from the Docker perspective, it's just that. It doesn't really matter if inside is an application server and you deploy your application onto it, or if you have your own Java main methods and you embed your Jetty and plug in your dependencies, whatever. So at some point, it doesn't really matter. So it's just how you develop this image. So we don't really care if it's running Java EE server on it and some application on top of it, or if it's just the Java main methods. There's really no difference that much. So technology. So what are some of these projects and software that enables Fabric8 to run? And the first one is Docker. So I guess you've already heard about it, so I'll just go through this. Basically what Docker is that Docker makes containers easy to use. That's the main thing that you just have to remember. And there are three things that makes up Docker. So the first thing is the Docker images. Those are the golden image that you use to whenever you want to run your application. The container, the created container from the image. So the images themselves are read-only, but you can create another image based on a different image. You can layer them. That means it's very efficient. And the images are based on some base image, and they use unified file system. So that when you create your own image, you don't store like 100 gigabytes of data. If you have some of the images sharing the same base image, you just store the difference basically. So that makes the creation of layers very cheap. So for example, you can have layer which is an application server as one layer, and you deploy your application to it as another layer, and this new image you just use as creating the containers and running applications on whatever platform that supports Docker. Docker registry is some kind of repository for the images. So there's one public Docker registry, something like GitHub, but for images. And so if you want, you can base your own image on someone else's image, even though it's probably not a good idea from the security point of view. You can have your private Docker registry if you want, of course. And the Docker containers is the implementation of the containers themselves. So now moving on to Kubernetes. Kubernetes is an open source project initially created by Google, and now it's, well, of course, the same project created by Google, but there's many contributors, including Red Hat and even other companies and stakeholders. So what it is basically it's an orchestration system for Docker containers. So basically what Docker didn't do until quite recently, it didn't really handle the case where you want to have cluster of nodes and you run in Docker on those, and you somehow want to manage those containers running on different nodes, and you want to connect them together. Basically, the linking of Docker containers was really only possible on the same machine. So and this basically is the thing that Kubernetes tries to solve, that you want to have a cluster of nodes, and you may want to declare that something depends on something else, and you want to communicate with each other. And there are three things that you need to understand when using Kubernetes. These are pods, services, and replication controllers. So what is a pod? A pod is a group of related containers placed onto the same host. Although usually there is really only one container, so for the purpose of this presentation and to make it simple, you can just think of pods as just something that inside of that runs a Docker container. Because there are not really that many use cases in which you use more Docker containers. There are, like in the A example, for example, you want to have MySQL as running as one Docker container, and beside that you want the admin UI as a different container, but they are kind of connected, so they must be deployed on the same host. So that's make it reasonable to have it in one pod. Okay. Sure.
I'm not sure if it's a good talk to ask.
Could you write a question for a microphone, please?
Okay, just is there a reason why I would want to separate all these things into pods and not have them in one giant Docker file that would have everything in place? Because that's usually what I'm seeing right now when I download Docker file.
In what? Why you want to separate MySQL and admin UI, for example?
Yeah.
Not because they're two different things, right? Because for example, there is a security issue in admin UI because it's some kind of, I don't know what it is, a PHP thing. So you probably want to upgrade only that, and you don't really need to just rebuild the MySQL because it's perfectly fine, so why do that? There are other reasons, but I didn't want to go into those details because you can plug in some data, some virtual data storages into pods, and those things share those data. That means those volumes, basically. So that's why it makes sense to have those in one pod and configure the volumes as a pod thing instead of. Right. Okay. So it makes yeah. If you're interested in the Kubernetes details, then I suggest you go to the Kubernetes sessions. And that's fine. Okay. Sure, go ahead and fire questions. I'm not really that expert on the details of Kubernetes, but I may answer what things I know. See feedback. Okay. The Kubernetes world is mostly a declarative world, which means the principle is that you declare all those things, resource reports and services and stuff like that, and then you tell Kubernetes the state of things you want to have, and then it tries to deploy things to fulfill this description that you provide. So everything is defined in some kind of JSON files or YAML files. There's a lot of boilerplate. The only thing we have to know is that, of course, in the pod, you define the container, and that means you need to define the image which you want to use, the Docker image. You may optionally have some environment variables that you want to inject into the Docker image. The container that was run from the image, not be precise. And you need to declare the ports which the container will expose to the rest of the Kubernetes. And services. The Kubernetes service is an abstraction of pods. Basically, the problem is that pods may be created, they have some address, and they place onto some node. The node may crash, so Kubernetes needs to create another pod, and that means the address of the pods may change. But you want to have something that stays the same even if everything else falls apart and is rebuilt again. So that's why we have services. So service gets its IP address and port, and the state is the same when it's created. And as an extension of those, basically, you can have more pods connected to the same service. And behind the same service, of course, any pods can connect to the service itself. But behind the service, we can have more pods, and then it will load balance between those things. But I mean, the service is useful even without all that. That's the thing. And that's what the replication controller does. That's the first thing. That's the third concept in Kubernetes. That's the thing that ensures that there are some certain number of pods running in Kubernetes. So if one thing goes down, you say that you wanted to have 2 of wildfire instances running. So if one of them goes down, then Kubernetes will spin up another pod somewhere if it has some space to wait. Okay. Yeah, and the thing is about services that if
what happens if a service goes down?
There's nothing. So. Yeah, the question was what happens if the service goes down. Well, the thing is that there's no tangible.
We need to for a stream.
Yeah, but you already repeated.
Oh, okay, sorry.
The thing is there's no tangible thing as a service. It's just a declaration in the etc in the directory. Basically, it's the etc daemon that stores every data in the Kubernetes. So it's just configuration of routing of Kubernetes. So there's nothing to go down, right? Really, like if the Kubernetes master goes down, then probably But suppose that eventually there will be high availability of the Kubernetes masters, and they will handle that case if that's something like that happens. But there's nothing like the service is not running process. It's routing. It's basically change IP table to do something. So it's what I wanted to say. So the important part is in microservices you want to have things depend on other things. So let's say pods depend on other pods. But as I said, the pods may migrate, may change their addresses, and so since they're created and destroyed. So you really need to not depend on other pods, but really depend on other services. That's the thing. Yeah, so the service definition, that's whatever, that's not important. The thing is that, so service has some ID, so let's say this service is called web. And then if you want to know the address of the service, then you can just, and every container that's running in the Kubernetes cluster, then you just ask, well, you just read it from the environment variable. So once you create the service, every new container that is created gets this environment variable, web service host and web service port, and you can just read that and you know where to connect to if you want to connect to the service. So I guess that's here. And now, good. I have too much time actually. Now moving on to Fabric8. Now, is there anybody who knows anything about Fabric as such, not necessarily this version 2 version? Okay, so just basically forget everything you know about Fabric.
I know the difference.
Okay. Yeah, good. So basically, the version 2 is really projects from scratch, but it's on the other hand, it's really trying to use the same ideas of the original Fabric. So anyway, we'll see that in the demo. Okay, so what it tries to be. Fabric tries to be an integration and management platform above the Kubernetes platform. Okay. We'll probably see, you probably don't have really an idea what it is, but yet, so we'll just hang on with that. So just two more concepts. That's basically Fabric really uses Kubernetes fully, so it doesn't require much more. So there are just one and two more concepts, and that's just Fabric application. And what it really is just a collection of Kubernetes resources grouped together and have some optional metadata applied to it. And the point of doing that is that if you want to manage it, so we want to have some management console that has some applications running on it, you want to have something that identifies what service and what this pod is connected to, like why is this pod running here. So you define some icons, for example, that so you can see the icon when you try to manage it, you see, okay, so this pod is actually running an image that is created from this application and so on. So it's really just metadata, this application thing in Fabric. And there's one more aspect to it, is that it's a template of the Kubernetes JSON files, so it's parameterizable. What's that different word? So you can, once you instantiate the applications, you can potentially provide some like specific environment variables and stuff like that. That's really just in detail anyway. So as I said, there's no such thing as Fabric8 runtime really, because it just manages things that run on Kubernetes. So, but there is one key component in it, which is the console, and that is using this based on the wholesale console project and thing, and also on this image. So basically, if you want to run Fabric8, you deploy Kubernetes. Either basically you just use the OpenShift free thing, it's probably the easiest thing, or you deploy just from the Kubernetes, Git repository, whatever, and configure it, and then you deploy the Fabric8 hotel image, and then you're running Fabric8 really, because it deploys the Fabric8 pod and the Fabric8 service, and everything else you do via that service. And that's the pattern of all the services that Fabric8 provides, actually. Apart from those services, it also has some tooling around it. So basically, everything that is part of Fabric8 is either a Docker image and the Kubernetes JSON files corresponding to it, or it's something that uses the Kubernetes APIs from the outside. That means some tooling. So the other part of that is tooling that allows you to create your own applications running in Kubernetes and Fabric8. Okay. Basically, the idea is that you should be using the same tooling as you always did as Java developers. So if you have some existing Maven built project that builds a WAR file that you just manually deploy to Tomcat, let's say, you should continue to do that, to just use the same build. So you just add some plugins, some Maven plugins that just enables you to also, apart from the WAR file itself, allows you to create a Docker image out of it. So you just configure, okay, so I want to use the Tomcat-based image, and I want this plugin to put my WAR file in it. And that's usually the default behavior of this plugin anyway, so if you just do that, it's almost no configuration at all. And that's it. It also has some Docker images that either are base Docker images for your own applications or some services that are useful for typical middleware scenarios. So what are some of those? First one is the ActiveMQ broker. Then there are some base images for base containers such as Keraf or Tomcat, Jetty, Wildfly, and so on. And last but not least, the base Docker image for using the plain Java, is the microservice kind of Java build that doesn't use any application server. And there are lots of quick starts that will help you to start with Spring Boot, Spring Camel application, CDI, CXF application, and lots of other things. So what are some of these services? Well, as I said, Fabric8 is quite a new project, so lots of these services either don't really work yet or are not that nicely integrated. So bear that in mind if you're going to try those. So one of the things is API registry. So we want, for example, if you deploy some CXF endpoints, for example, or Regex AWS, you want to see in a central way all those running inside your Kubernetes cluster. So that's what the API registry does. It analyzes all the running containers and gets this information from it. API management using APMan and Keycloak. Unified logging that grabs the Docker logs and centralize them in the central location using Elasticsearch and Kibana. Some metrics things, and probably lots of other things that are either under development or well, I've basically ordered this from, no, not really. Yeah, but I mean, the API registry is kind of working. Unified logging is also kind of working. Metrics I haven't really tried. API management kind of works, but you need to configure it manually. But yeah, demo time. Hopefully. Okay, it seems it's still running. At least something is still running. So hopefully. So what our demo application will look like? Suppose we are an Acme international company making tool sets like anvils and stuff. And we have two inventory systems like distribution centers. One is European-based, one is US-based. And we want to have a single international web shop for ordering these tools. So we want to have some application that will put this order into the proper inventory system. Okay, simple enough. So how it will look like? So we will have some front end, which will be a JSF application running on Wildfly. Then it will put these orders into an ActiveMQ broker in some queue. Some Camel application running on Keraf will take these, and then based on the route, we will distribute either to European or the American. So it's kind of a microservice in that. So we have several components running standard protocols, ActiveMQ, or using that's probably REST endpoint just. And it's using different, you can see we'll be using different application server, like application server and graph and simple Java main methods using embedded Jetty, I think, application. And I think I'll do this thing. So finally we see it running. Something is happening. Okay, so this is the console. You can see the application is running. So the console is, of course, the Fabric8 console itself. Kibana and Elasticsearch are doing the logging stuff for us, maybe, if it works currently. Let's see. Okay. And then there are some tabs to see the Kubernetes resources, so we can switch to pods if you like. And that's not true, and just refresh it. Okay, so we see some ID, which is not important, some status that it's running or some problem with it. We can see the images which are these containers are based on, some IP addresses and some labels, which are some another Kubernetes concepts which I haven't talked about, which is not really important for this presentation. We can see the replication controllers. So here you can directly set how many replicas you want to have, if it makes sense. And services. The backend applications, which are the European and American distribution centers, directly have some web user interface on it. So we can just click on the address and see those. So this is the European inventory system with some mock data in it, and this is the American one. Red, white, and blue. Okay, so let's deploy some more to it. I've mentioned the API registry, so let's start that. And also, what was missing here is we will eventually need the Fabric8 MQ. This is the active MQ image, so just click run. You'll see that something is happening. You may see that the pods are being created, hopefully. Unknown is probably downloading the image or something. And yeah, you may have noticed, it's not really obvious, but the API wasn't here before, just a moment before. So that's one of the cool things about Hot.io, that it enables you to just dynamically enable views, which makes sense in the current context. So if we have API registry, the API view just was available, and we can use this. We can see, for example, that it discovered this service, this endpoints. So these are some probably REST endpoints that are available. So we have the European and US backends. We can open the Swagger UI to see some more details about them. So, and we see that the order service is really very simple REST service. So we see that, for example, the registry API allows you the API registry allows you to see what are you running. Okay. I really hope that MQ is really working, because we really need that. Yeah. Okay. Well, it's green. Fine. So let's now deploy also the front end. And eventually it will come up, it will light up this address. So this is a very modern looking JSF application. So let's order some Acme toolboxes for me, Faculty of Information Technology in Brno. And order, and it thanked me for my order. Now you may have noticed that there's one piece of our application missing, which is the camel route. So which means that the order is probably hanging somewhere in the queue. So let's open the pods view, and you can see this little arrow here. It means that Fabric8 discovers that there is some Jolokia running inside a container, so it enables the host IO to connect directly to the container. Yes. So you see, even though I'm still in the same console, I see actually the console of the container. And here it is. That's the DevCon queue. It's one piece in it. I can probably browse. Yeah, and that's the message. It's a simple XML message with my order. Great. Okay, so I can now deploy the camel routes. You see, it's based on the quick start. I didn't bother changing the documentation of that. And once that gets deployed, it should automatically pick the order from the queue and call the proper REST service of either the US or the European endpoint. Since I've already for the Czech Republic, it should appear here. And it's not here. So something happened. It's not yet. Okay, something in some waiting state. I'm not sure if I know what that means. And it's green. Good. Let's try again. I mean, not try again as such, just refresh the it's there, so it works. Great. So what can I do next? So, yeah, I can do the same trick with the camel stuff, since it also understands that it's here. I can directly log into the camel container. You can see the routes, display the route diagram, for example. We see it's a simple camel route that based on some regions supported, based on the country of the order, it puts some header into the message, and based on this header, it decides whether it goes to the US route or the EU route. You may, and these are the endpoints. You may wonder why this is something that looks like hard-coded addresses. They're not really hard-coded. They just create this. I can show you the source code of the route. So there's a route builder. So as I said, in Kubernetes, you need to discover the service addresses from the environment variables. So inside Camel, you can, in the route builder, you can just get them by system getenv, and that's how you can do it. For example, I mean, since actually this interesting thing about that is since it's now common in the cloud environments to have these things in the system environments. There's lots of like feature requests for example, for the Camel, the blueprint stuff to easily use the environment variables in the routes and stuff like that, because that's how we want to use it, really. So I don't write that you need to call system getenv. Hopefully, it will be better, nicer ways. As for the MQ, it's since the Camel application has the Fabric8 Java library that will automatically configure the MQ endpoints to get the service, the Kubernetes service of the active MQ broker. So you don't need to configure anything. It's just if you use the library, then it's automatically configured. It's nice. And the last thing I wanted to show you in this demo is the centralized logging, which is the most fragile part. So it seems that this is running. So it's based on Kibana. So basically what I'm showing is just showing Kibana. I need to trim the fields a bit, so it actually makes sense. I'm not interested in the registry, not the console, not the image, not the MQ. I'm just interested in the containers running the front end or the back end, and we really see those messages here. Yeah, we see, for example, here that the front end logged that it was sending the order, while the European backend logged that it received the order. So we can see all the logs from all the containers in one place. We can search from them and just use Kibana. It's neat. And that was the demo. Any questions from the demo? So I'm just not really finished, but If you want me to.
Just taking microphone for a
Oh, okay, fine. Okay, so Fabric8. Okay, so what are some of the additional tools that are part of the Fabric8 project? So I already mentioned the Maven plugins that allows you to create the Kubernetes templates just by configuring properties, Docker images, and the Jube zips. I will talk about Jube in a minute. Yeah, I think. Some of the Java libraries, so for example, Java libraries for Java APIs for Kubernetes and Docker. There are some ActiveMQ helpers, like the one we saw. And there are also some RPM extensions that allows you to test, and some assertions for Jolokia and for Kubernetes and stuff like that. So how do we build this thing, your applications that is? So the problem here is that it's not just one artifact that you build. So from one sources, we want only on one hand have the Docker image and put it into some Docker registry. What's the name, whatever. And on the other hand, you want the Kubernetes JSON file that describes this, plus some services and stuff like that. And optionally pack it into a Fabric8 application. That means maybe putting some icons, metadata into it. So here's how the usual Maven build looks like. So you have some POM files, some sources. You use Maven clean package to just get the app.war and that you manually or using some additional Maven plugin to deploy to your container of choice. Whereas with Fabric and Kubernetes, you need to configure 2 plugins. So there's one Docker plugin and the most important part that you need to configure there is the base Docker image that you are basing your image on. Fortunately, as I mentioned, Fabric8 really provides lots of. Is that time now?
Yes, fine.
Okay. Fine. That's fine. So I think those things are quite obvious anyway. So, I mean, based on the things I've already talked about, right? So yes, you have Docker plugin, Fabric plugin, and that's fine. So yeah, okay. If you want to know about Jube, I just say what it is. It's a Java implementation of the Kubernetes API that allows you to use Fabric even without Docker or Kubernetes. And if you want more about that, I guess you guys need to ask me. So any questions? I've also prepared one additional demo using Jube, which is very boring because it's using the same stuff. Okay.
Sorry. My question is, does Fabric8 help me anyhow to combine Java and non-Java related deployments?
Well, yeah, on some level, it's just Docker images and Kubernetes services, so sure. But like, well, so on one hand, you can, of course, have everything that I was running and you just deploy any Docker image in it. Like use the console to deploy any image. And you can, your Fabric8 application can, of course, describe any Docker image also. So you can have the application which is not Java related at all. So you can deploy it using the console and that helps you.
Mm-hmm. So it will, for instance, somehow discover REST endpoints that are available?
No, unless you implement the same API as is used there, of course. But of course not. I mean, that part, of course not, unless you implement it. Yes.
Okay, thanks.
Okay.
Okay, so thanks a lot for the presentation. And now we'll have the lightning talks. They're not going to be here, but we're going to show you the schedule on the screen in a minute.
se trénoval, tak jsem to vždycky stihnul, ale tyjo, jestli člověk interpretuje prezentaci vždycky tak rozpovídá, že ale tak to všechno důležité jsem tam já, takže to je.
Guys, I'll do that in a minute, okay?
Martin, how are you? Sometimes there is like one or two. Yeah, the thing is, I said I made this presentation this morning, and I said we'll do the same thing next afternoon. So I think people were like, okay, it's like maybe on the same day, same room.